This is our proposed exercise. At point A, we have a pin support, which will give us a vertical reaction as well as a horizontal one. At point D, we have a vertical elastic support, which will give us a vertical reaction. At point E, we have a roller support, which will give us a horizontal reaction. This leaves us with 4 reactions. Those are more than the number of equations that we have, or we could have if it weren't for the hinge at point B, which decreases the degree of indeterminacy of the system by 1. We will have a sign criteria of positive forces that go upwards and to the right, and positive moments that rotate in counterclockwise directions. Let's write down our 4 equations. The sum of all vertical forces in the system must be equal to 0, as well as the sum of all horizontal ones. The sum of all moments at any point must be equal to 0. We will choose point C. The sum of all moments both to the left and the right of the hinge must be equal to 0. We'll choose the left side, as this will lead to simpler computations. We have 4 unknowns, so we don't need to compute the right side of it. Let's develop these equations. The vertical reaction at point A goes around C in a clockwise direction, thus the negative sign. However, the horizontal one goes around it in a counterclockwise direction, thus the plus sign. The same applies to these 2 reactions. We know, thanks to this equation, that the reaction in a horizontal direction in point A is equal to 0. With this in mind, let's write again our system of equations. We also change a few things up. This equation tells us already that the value of the horizontal reaction at point E is P. Let's now take these 2 equations into the third one. This leaves us with an equation with only one unknown, the vertical reaction at point A. Let's compute it. This is equal to 0. Therefore, the vertical reaction at point D, according to this equation, is 0 as well. We have now all 4 reactions. With this information, we can now draw the axial, shear, and moment diagrams. From A to B, there are no axial forces, as the vertical reaction in A is equal to 0. Nor are there any shear forces, for the same reason with the horizontal reaction. There are no bending moments, for there are no forces to generate any moment, nor are there any moments applied. The same stands for the section BC for all 3 diagrams. From C onwards, we have the moment M. So, in the bending moment diagram, we'll have minus M. However, the axial and shear diagrams are unaffected. DE has no axial forces, as the vertical reaction in point D is 0. However, we have shear force, P. So we'll have minus P. In the bending moment diagram, thanks to the knowledge that in point E there are no moments applied, we know that the diagram will go from minus M, the value it previously had, to 0. Thus, the 3 diagrams are computed and the exercise is solved.